Okay. So remember, little f is the before the antiderivative, like a function that you've already taken a derivative. This is right before a derivative happens. In other words, you're going in reverse. So, but this time they are definite integrals. So they give you some number from a to b. So you plug into b first to the function that you find, subtracted by the function at a. You just plug them in. Okay. Where capital F is the antiderivative of lowercase f on a to b. Okay. The notation that you will be using will be, I'll just add another extra step here. So you integrate from a to b of some function relative respect to x. Then you will find the antiderivative, but don't actually input the values yet. So you'll write it to the side. So I have my antiderivative, derivative from a to b. Then I evaluate the new function that I found at b and a, top minus bottom. And that will be your answer. So do an example. The integral of from 1 to 2 of the function x squared minus 3 dx. So you're going to have to separate them. Remember, we said we can integrate things separately, right? So you will get x cubed over 3 minus 3x from 1 to 2. You see what I'm saying? This is capital F right here. Oops, somebody waiting. Okay.
So you just separated the everything inside the parentheses to like its own integral?
Yeah, so you just do them separate. So integral of x squared is right there. Integral of 3, 3x.
And then you got the divided by 3 following the product rule, correct?
The power rule, yeah.
Power rule, yes, sir.
Yeah, that's where it came from. You do the +1 divided by +1. So on this section, they're assuming you're comfortable with the integration stuff. But if you miss something or you don't see what happened, let me know. It's not a big deal. But the new stuff starts here. So we evaluate the function at 2 minus the function at 1. So that will be 2 cubed over 3 minus 3 times 2. So all this stuff minus the same function again, but at 1. You see how this is, where these numbers are coming from? And then you just add numbers and you're done.
We're just using the limit, right?
What's up?
We're multiplying by the limits, right?
These little bounds. You're right.
Oh, okay.
Plug
That's
them
cool.
in. Plug in the 2 here. I plugged in the 1 there. That's what this formula is telling you up here. Capital F is the antiderivative, which is this guy right here. And then you plug in the B minus the A. So that's the basis of the fundamental theorem. So that will be some number that I don't really care about, but let's see what it is. It'll be 2 to the third is 8. So 8/3 minus 6 minus, that's 6, that's kind of weird. Minus 1/3 minus 3. So negative negative will be plus 3. So that will be 7/3 minus 3, which will be
Raise it up a little, please.
oh yeah, sure. Sorry. I mean, this last part is just fractions, right? Who cares? But it should be negative 2/3. Anyway, did any of these steps make sense?
Yeah, I'm understanding
I
that.
think we're okay, or I'm okay at least.
Yeah, I'm understanding it so far.
So far, just let me know if at any point something just doesn't make sense. It's not a big deal. All right, let's do another one here. All right, so the integral from 0 to pi over 4 of secant squared x dx. So what is the antiderivative of secant squared?
Cosine. No, 10.
Yeah, tangent, that's right. So tangent x. And we got to evaluate this new capital F from 0 to pi over 4, which will be tangent of pi over 4 minus tangent of 0. So that will be 1. Okay. We'll move on to something else. Sort of related though, but so these problems can also find the area. So what you do is you graph the function, and then you integrate from a certain point, like let's say 0 to pi over 4, and you find the area underneath the curve. So let's see if I can find a good one for that. Maybe I can use this.
So did you take the derivative and then you
You take the antiderivative.
and yeah, the antiderivative, and then you just plugged in the numbers or
Yeah.
started them?
Yeah, that's pretty much it. You plug in the top one, and then you plug in the bottom one, but you subtract. Upsides down. That's weird. Oh. I'll just have to graph it by hand. I'm gonna turn the page. Is that cool, or you guys still reading it? Alrighty. For this example, 3, I think. Where am I on the screen? So find the area of the region bounded by the graph y equals 1 over x, and the axis and the vertical line x equals 1 and x equals e. So it's kind of hard to visualize without graphing what the heck's going on. So what the fundamental theorem of calculus will help you do is compute the area underneath this region that's bounded by all these pieces. So the 1 over x graph, right? You guys remember what that looks like? Right, so looks like this. It's a shitty drawing. Static. That. This. Do you remember?
Yeah, I remember now.
So then they said it's bounded by the axis. Okay. Vertical line, let's say 1's right here. Bounded by this line, x equals 1. And bounded by the line x equals e. E is about 2.17, whatever. So we'll say e is about here. So they want to know, what is the area bounded by all these pieces? So I want you to start graphing these before you start. This is going to get very important in the next chapter. Okay. Right now you can get away with not doing it sometimes, but I don't recommend you start doing that. So I'm going to integrate with respect to x the 1 over x function. Since with respect to x, that means I'm going this way on the x. So in the theory, if you look at the book at all, they have rectangles with thickness delta x going this way. So I just need to know, since with respect to x, and we know the bounds, 1 to e. So I'm integrating from here to there. So the actual integration is not too bad. Graphing might be difficult if you haven't graphed by hand in a while. You can use some calculators to help you out, but sometimes it's kind of easier to just do it by hand. So anyway, what's the antiderivative of 1 over x? Or which derivative gives you 1 over x? You guys remember?
I think we have to invert the fraction, like x to the power -1, and then we add 1.
That rule does not apply when the x is 1.
ln x.
Yeah, it's going to be ln x. So this is one of the ones you have to memorize.
Oh, yeah, I remember now.
So 1 to e. So plug in ln e minus ln 1. Ln of e will be, will cancel out, leaving me with 1. This will be 0.
It's a natural log of x, and then natural log of 1.
Yeah, natural log of 1 is going to be 0. Natural log of any base, when you put any log of any base evaluated at 1 will be 0. Okay. Any
I
questions
guess
about this?
I got the solution, like how you do it, but the graph, if you can tell me how you graph it this way, very quick.
Yeah, so you have to be able to understand what they're telling you, right? So they said the region, this is the region, right? The shaded part.
Yes.
Region bounded by the graph. So first I got to graph 1 over x. So that's this guy, right? Then it says bounded by the graph, the axis. So the axis is going to be this bottom part.
The x-axis, yeah.
Yeah. And the vertical line, x equals 1. So that's going to be vertical line. Because whenever you graph the function x equals 1, it's always a vertical line, right? X
Okay.
equal e, another vertical. So all these graphs closed off this piece.
Got you. Thank you.
I guess I missed how you managed to get the natural log from the integral, like as the antiderivative.
So what's the derivative of ln x? Do you remember?
I don't.
It's one of the ones in the it's on your I think I sent you that form in the sheet. It's kind of something you just need to remember.
I believe I have it. Let me open it.
Okay. It can also be derived, but it'll probably take 30 minutes. Excuse me.
So that always follows the x-axis, right? When you're following
Usually it tells you which axis.
the vertical.
So it'll tell you like y-axis or x-axis.
So the y-axis will be horizontal, right? That's the
Right. The y-axis is the vertical.
vertical.
Hmm.
That's it. Okay. So the x-axis will be horizontal then.
Yes.
Okay. That's backwards then. Thank you.
No, it's okay. I get dyslexic all the time. I forget which is which. Let's share this real quick. So these are the derivative rules you kind of need to know. Can you guys see this on the right side?
Yes.
Yeah, so the derivative of ln is 1 over x. So the integral of 1 over x is going to be ln. So you kind of need to, I mean, the derivatives you should already know, but if you've forgotten, that's okay. But knowing the derivatives helps you go backwards, right? But in this class, I'm sure you'll get used to both of these steps eventually. Oh, also a quick note, there is no c, did you notice that? We're not adding plus c.
Why is that? I thought we were always supposed to have a plus c too.
So the plus c is for indefinite integral, meaning there is no bounds. So if I don't give you bounds, then you have to put c.
So it should be 1 plus c?
Since you put 1 to e, you don't put c anymore, plus c.
Because it doesn't have
What's that?
Oh, got you.
because we don't have any bounds. We don't put
Yeah, exactly. Yeah, if you don't have any bounds, then you put the c.
if we had bounds, we put c.
But if you put the c right now, let's say you forgot, it's going to cancel out right here because you're going to have what? Plus c minus c, right? So it would be gone regardless, even if you put it by accident, if you do your math correctly. But I just recommend don't write it. Not if there's bounds, don't write it. Easier that way. So average value. So if they ask for an average, this is the formula you need to use. So if f is integrable on the closed interval a to b, then 1 over b minus a times the integral of a to b of f of x dx is the average value. Average value of f of x on the interval. Okay. All right, let me give you another theorem real quick. This is the fundamental theorem of calculus part 2. Whenever you hear that in a math book, I mean, it's very important. Fundamental theorem. So if f is continuous on a to b and capital F is equal to the integral of ax of f of t dt, then f prime of x is equal to f of x on this interval a to b, closed interval. So example would be, let's say the question would be something like, find f prime of x given capital F is equal to this integral pi over 2 to x of cosine t dt. So the integral of this would be sine, right? Sine t from pi over 2 to x, which would be yeah, which would be sine minus 1. Let's skip those small stuff there. Just plug in the values, right? So the derivative, so if this is capital F, then so F derivative of x would be equal to cosine x minus 0, right? Because you take the derivative of this guy, giving you cosine derivative of 1, 0, which would give us the beginning value, right? It was here, sine f prime. So f prime is just cosine. So what the formula tells you basically, because I know it seems weird at first, right, is in a nutshell, taking the derivative of both sides of this integral equation will cancel the integral, leaving you with just cosine at that x. See what I mean? You can just jump straight to here. So that's what the fundamental theorem part 2 lets you do. So it's given f, f prime will just be echo. From Cal 1.
It's such a pain.
So the chain rule is basically the foundation for this next integration technique. So in Cal 1, you learn a bunch of different derivative techniques, right? So in this class, you're going to learn a bunch of integration techniques. So the hue substitution kind of helps you deal with the kind of like undoing the chain rule in a way. Okay, so hue substitution consists of pattern recognition. And a change of variable. So the point of this technique is to make the question easy enough to integrate using the basic techniques. But before we get to the new technique, let's recall the chain rule. So the chain rule is needed when you have a function composed with another function. So if you were to take a derivative of a function f with a function g composed inside, the formula told you to do is take the derivative of the outside, right? And leave the inside alone, and then times the derivative of the inside. That's what you had to do. Which means, if we go backwards, the integration of f prime of g of x times g prime dx is equal to f of g of x. You see what I'm saying? So if you take a derivative of a composite function, you'll get these pieces. But if you integrate something that looks like this, then you go back to the composed function. So that's what we're trying to do. We're trying to identify is, do we have something like this? Can we use hue substitution to get it ready and jump to there? So the first part is learning how to identify the hue substitution. So the way you do it, so you let the u equal the g of x. This is the inside function, right? So it always has to be the one inside, or the more complicated part. Then du, derivative of u with respect to x will be g prime of x, right? In other words, du is equal to g prime of x dx. So if you multiply the dx on both sides. So if you were to sub all this, right? So this is what I want you to recognize. This u is the part that's in here. Here. G prime dx is equal to du. So I can replace all this with du. So let's show that work. So capital F is equal to the integral how do I phrase this? Yeah, F prime of u du. So this right here is du, and this is u. Does that make sense? So using this idea, we were able to simplify the question and integrate this. And once you integrate that, it's just going to be f of u. But then we need to separate, or sorry, we need to bring back the c. And we don't care about u because that was just a dummy variable, so we change it back to x. And that's what we're trying to find. F, capital F of x. We just have to go a roundabout way because we have a composite function. Okay, so remember this is the outside function. This is the inside. This whole thing over here is the derivative of the inside. So that's what we're going to do with some actual examples now. This is all general. So this is the point. Why are we doing this? Integral of x squared plus 1 squared. Let's make it harder. Let's say this is a 5 times 2x dx. So technically, you could FOIL this 5 times and then multiply by 2x and then integrate piece by piece. You probably have like 30 terms. But doing that is not fun. So you're going to use substitution to help you out. So substitution will make the question easier or make it possible to be solved, because sometimes it just can't be done unless you substitute. So the trick to using this technique is learning how to pick the u, because that's on you. They're not going to tell you. So let u be the inside. Usually it's going to be the inside of the more complicated part, or sometimes it's going to be something in the denominator, or inside of a logarithm, or inside of a square root, stuff like that. You start to see a pattern after doing these a while. So u is going to be this guy because it's so difficult to deal with. So x plus 1. du, the derivative of u, will be, with respect to x, will be just 1, right? If I solve for du, I'll have 1 dx. I messed up. That should be x squared. Oops. Let's try that again.
Lift it up a little bit.
Yeah.
Thank you.
So u will be x squared plus 1. That's inside. du will be 2x. du dx will be this guy. du will be 2x dx. There we go. After a while, people tend to skip this middle step. They go straight to there, which is what I do. It's whatever. I'm just doing this for you because a lot of people wonder what the heck is du and why is this way? Is it because of this? Okay, so then go ahead and substitute. So notice we got right here, that's du, right? You see that? It's right there. U is in there. So substitute. So now we have u to the 5th du. Do you see how the substitution happened?
Yeah, I see it.
So then just integrate. Now that it's an easy question, you just do the power rule, right? That's going to be 1 plus 1, 5 plus 1 over 5 plus 1 plus my c, which will be u to the 6 over 6. But nobody cares about the letter u. We're looking for an f of x function, so we must replace it. We get back to x squared plus 1 to the 6 plus c. So that would be your actual answer.
Can you move it down a bit? Thank you.
Is there any questions about any of these steps?
When is the last step? When u power 6 over 6 plus c, we get from it, we get x squared plus 1 all power 6. How we get rid of the denominator 6, the 6.
Oh, I just forgot to write it. That's supposed to stay. You're right.
Okay, thank you.
Any other questions? Now I'm going to turn the page and do another one.
It's the same way we do the square root, right? We just pull the stuff out.
Pretty much, you'll let u be the stuff inside the square root. Well, we'll do one of those in a bit. Sometimes it just requires you to be really clever, because it doesn't always look like a u substitution problem, and then it is. It turns out to be way easier once you do it. But you just need to practice. All right. This is the integral of 5 times e to the 5x. My 5s look shitty, but it's a 5. So what do you guys think the u sub should be?
5e?
And if you choose 5e, or what do you mean?
Yeah, 5e.
5e to the 5th. You can pull the 5 out, right? And then you'll have e to the 5th of xx.
Yeah, you could do that, but the the e is attached to the e to the 5x. We can't just sub only this. So we can
Yeah.
sub the whole e part, or we can sub the 5x part.
It'd be the 5x.
Yeah, it's going to be the 5x because we have a formula, right? We know that integral ex dx is itself, right? Just like the derivative. But you add the c for integrals. So we let u equal 5x. So du will be 5 dx, right?
Yes.
And we have a 5 and the dx right there, right? So looks like we're good. I can rewrite it for you just so it's more obvious. E to the 5x times 5 times dx, right? I just moved them around. I didn't do anything special. So this right here is du. And this is u, right? So that will be the integral. So do the substitution. E to the u du. And the integral formula tells us that will be e to the u plus c. And then we just substitute back what u is supposed to be, and we're done. Does that make sense? So this is your second integration technique.
We dropped the 5 because it was a constant, right? Right here.
The 5 was
From 0.
substituted by the du.
Okay. All right. Check now.
And then when we integrate, du or dx or whatever is gone. But remember, we're kind of like, it's like we're undoing the chain rule, right?
Yeah, I understand it.
Okay. Do something a little bit different. So far, our u and du made it perfect, right? Everything that we needed was there. But let's say it's not all completely there, it's almost there. For example, this guy here, x times x squared plus 1 squared. What do you think u should be?
X squared plus 1.
Yeah, I think that's a good one. X squared plus 1. So du will be what?
X.
Has to be the derivative of both sides. So du and
2x. Sorry.
yeah, 2x. Okay, but do you notice the problem for the substitution? Oh, I forgot something first of all. Do you notice that there's no 2, right?
Correct.
We have 2x dx, so I can't substitute du because I don't have a 2. So that 2 is just effing it up. So what you have to do is divide both sides by 2 to get rid of it, because it doesn't exist in the question. So now du over 2 is equal to x dx, which is what we have, right? We have an x and a dx. Do you agree with that?
Yeah.
I'll rewrite it just so you can see it better. So this is u, and now we have du over 2 is right there. You see that?
Yes.
So now we know we can sub correctly, because when you do substitution, you better not have any more x's anywhere, right? So that could be gone. That'd be u squared du over 2 once I do the sub. So that 1/2 there, let's just pull it out. It's no big deal. You're great. That will be, what's the integral of u squared?
Two x squared.
An integral of u squared. Right, remember, we have to use the power rule, right?
U3 over 3.
Yeah, 2 plus 1, 2 plus 1. Don't forget the c. Once you start applying a rule, you no longer write the integral. Now we have u, 1/2 times u cubed over 3 plus c, which gives us, let's do it, 1/6 u cubed, which is, and I already forgot what u was so long ago. U is x squared plus 1 to the 3rd power now over 6. Does that make sense? Is that weird?
A little hard. Maybe while we're doing the homework, maybe we can view.
Yeah. Yeah, that's fine. Let's see here. It'll make more sense once you do a bunch of them, because you'll start to see that the trick is picking the u. If you pick the wrong u, the way you realize it's wrong is by doing this. Like, check it out. Let's pretend, I'm just gonna do some made up scratch work over here. Let's pretend I say, you know what, I don't know what u should be. I'm gonna pick this whole thing, I don't know. Let's say I did this. So I'll let u be this. But if I take derivative of that, I'm gonna have to do a chain rule, right? So that would end up with something not at all helpful. Right, that would be the derivative. And that's nowhere in the question. So if you notice that the derivative does not appear in the question, then you chose a wrong u. So right away, you know what, that was stupid, let's not do that. See what I mean? Or if I chose, let u be x, I don't know. Du equals dx, that doesn't help me at all. It's the same question, it would just have u's everywhere. That would also be wrong. So you can try different things and then check, does the du appear anywhere? And if not, pick something else.
I just had a question. I didn't hear when you said, why did we put it under divided by 2? Du over 2.
Why is it over 2? Is that what you're asking?
Yeah.
Let's see here. So originally, so you're cool up to this point, right?
Yeah, I got everything and I understood the work. I just didn't know why we did.
So when you get to here, you look at the question. So the idea is I'm picking a u and a du that will replace stuff, right? But this du, it doesn't help me because it has a 2 on it. there is no 2 being multiplied anywhere. So I had to divide it out. And once it's divided out, then I have this guy, x dx. Now I can replace it with d over 2. Once that's done, just pull out the half, and you can take your power rule.
Okay, gotcha.
So sometimes if you see you're missing something, you might have to multiply both sides or divide something out. Depending on what's going on, you have to do, because it's still an equation, right? So you do your algebra to make it help you. You force it to substitute. So you can't have u's and x at the same time. All right, let's do another question. Let's do a square root. So this whole section is finding a u sub. So there's only one thing to substitute, right?
2x dash 1 minus
Yeah, that's right.
it'll be 2 times 2x plus minus 1
And then du will be,
over raised to the 1/2.
yeah, we'll have to do that in a little bit. Once we do the sub, we'll have to deal with that 1/2 power. But currently, we did the u's. We chose a good u, because stuff inside of square root most of the time, that's a really good choice. I'd say 90% of the time. Sometimes picking the whole thing actually helps you, but it really depends on the question. But anyway, there is no 2d, oh, sorry, that's a typo there. There is no 2dx, right? There's only a dx. So I need to get rid of the 2. So I will divide both sides by 2. So now du
I have a
over
question.
2.
Why you are
Okay.
looking for 2dx? You said there is no 2dx. Why is this important?
Because I need to replace it. Right? I'm replacing this here.
Oh, so we're trying to get this? Okay.
Right. If there was a 2 here, then I would just replace the whole thing with du, but there is no 2. So I need to make it look like that particular dx.
Got you. Thank you.
So then we can just go ahead and do it. So that'll be square root u du over 2. So that's what dx is equal to, right? Pull out the 1/2. Change the power to 1/2 power. And then begin your antiderivative. So u to the 1/2 plus 1 over 1/2 plus 1. That will be u to the 3/2 over 3/2, which will be, do some fraction stuff here, and it'll be 3u 3/2 plus c. Right, you flip this fraction over, multiply. Is that right? No, that's wrong. It's 1/3. Sorry about that. So once it's integrated, you replace the u and you're done. U was originally this here.
I have a quick question. Can you hear me?
Yeah, well, what's your question?
Okay, I'm sorry. When you pull out the 1/2 and then put it back into the problem, are you applying the 1/2 just to the u or also the constant?
That's a good question. Technically, it would be both, but c is any constant.
Okay,
Half,
so when
half of any constant is just some other constant. So you could multiply that c by 1/2 and then rename the c to c2 and just move on. But or we can just pretend that never happened and leave it as c. It's really however you want to think about it.
okay, yeah, because I think in the homework, I think it was like a longer chain. We had to apply the whatever we pulled out by each, value. Okay, that makes sense. Thank you. Sorry.
Yeah, if it was an actual number, I'd say do it. But if it's just a c, don't worry about it. It's not
Okay.
going to mess anything up.
Cool. Thanks.
Does the 1/2 turn into the 1/3 in the front because we're adding 1 to it as well?
Oh, this what happened there? Is that what you're asking?
Yes.
Yeah. So we had this situation, correct? So then you flip it over and multiply. So the 2's cancel. So I skipped the fraction step. The fraction step there. Do you see
Okay.
how it happened?
Yes, thank you.
Okay. Any other questions before we go to the next one?
No.
All right. The next one is kind of weird. This is when you got to get kind of clever. I never like these kinds because it's not obvious and you just got to like keep trying stuff. But since we know that the only techniques that we have right now are substitution, so that's what we're going to use. What do you guys think is a good U? It's not obvious, but let's say we stick with our rule about inside a square root. The issue is that the derivative will not be there. So we have to kind of game the system. All right, so we have du equal to 2dx. So what we can do is solve for x using the first part, right? Because we know that u is equal to 2x minus 1, so what is x equal to? X would be equal to, move it plus the 1 over, divide by 2, and u plus 1 over 2, right? If you solve for x. So I can replace this x with this guy. I can replace this dx with this, right? And I can replace the u. That way we'll no longer have any kinds of x's anymore. But you see how this is kind of weird? Like that wasn't obvious. You kind of had to try stuff. So when you get stumped and you notice that no sub you can think of is working, try to solve for x in the u that you chose and then plug that in. Again, a lot of this will come with experience, so you just got to keep practicing. So x is equal to u plus 1 over 2, right? So I replace this guy with this times square root of u times dx, which is du over 2. So it's all replaced. I'm going to pull out the half because that looks weird. Currently I have u plus 1. Yeah, I'll just write the other way. Yeah, I guess that's fine. I have u plus 1 times, I'm going to go ahead and change the square root to u to the 1/2, okay? You guys still with me at this point?
Yes.
Yes.
Looks like I forgot something. There's a half here and a half there. This should be a 4th. Right?
Yeah.
Okay. So we're going to distribute the u and then see if we can integrate. Because right now it's still sucks. So u the 1/2 times u, that'll be u to the 3/2 plus u to the 1/2 du. So now we can just integrate these guys separately. Separately, and then we'll deal with the 1/4. So this will be 1/4 brackets times the integral of u to the 3/2 du plus the integral of u to the 1/2 du, which will be power rules, right? There's 3/2 plus 1, divide by the same thing, 1/2 plus 1, divide, and then deal with all the fractions. So here we go. So 1/4 times all this nonsense, we're going to have 3/2 plus 1 will be 5/2 over 5/2 plus 1/2 plus 1 is 3/2 over 3/2. That doesn't look pretty, but oh well. 1/4 times, flip over the 5/2, so that'll be 2/5 u 5/2 plus 2/3 u 3/2. Almost done here. Let's shrink this a bit. Last little space here. So that will be, distribute the 1/4 then, you're going to get 1/10 u to the 5/2 plus 1/6 u to the 3/2, and then bring back what u is supposed to be. Then we have 2x minus 1 to the 5/2 power over 10 plus 2x minus 1 to the 3/2 power over 6. And I forgot my c along the way, but oh well. Yeah, I'm sure my math teacher will yell at me for that one. Okay. Is there any steps here that are kind of weird, or if I lost you somewhere? These are one of the hard U sub questions. They're not all like this. This is like the towards the end kind of problems. You know what I mean?
I'm tracking so far.
That's good. Then maybe this section won't be too bad for you. A lot of people struggle with the U because it requires you to see the pattern. So once you start seeing the pattern, it'll become easier. But if you just got to figure out and learn what is a good choice for U sub, okay? All right, for this guy, what do you think a good U sub will be? Or would help?
Sine 3x.
Yeah, I think that's the good one because it's the most complicated part, right? Has a power. So U will be the sine 3x. What is du? What is the derivative of sine 3x?
Negative cosine.
Cosine 3x.
Yeah, it's close. It's going to be 3 cosine 3x, right? Don't forget the chain rule. So, is that in the question? Do we have a 3 cosine 3x?
No.
We have cosine 3x on.
Yeah, so we got to get rid of that 3. That's not supposed to be in the substitution.
It's a bit blurry.
Yes. Strange. I don't know why it's doing that.
That's good right there.
Thank you.
Okay. Yeah, I don't, it's just adjusted on its own. Sorry about that. Okay. So I skipped the division step. I hope that's okay. Divide by 3 on both sides, and now we can sub, right? So this right here is du over 3. This guy is going to be u. So here we go. So now we have u squared du over 3. And now the question looks much simpler, right? To pull out the third, and this is a question that you should be able to do no problem. It's just a power rule. So add 1, divide by the same thing. So that will be 1/3 u cubed over 3, which is 1/9 u cubed plus c. But nobody cares about u, so change it to what it's supposed to be. And that'll be it. Any questions about any of those steps?
The only question, I'm sorry, is the 1/3. From where we get the 1/3 at the top? The second equal 1/3 integral u squared du.
Oh, it's from this, the du over 3. I've pulled it out in front.
But when you pull it out at the front, it's not multiplied by the u2 square and du as well. Like we take it away from one part only of the equation.
Well, this is all times, right? So.
Ah, yeah, there's the same thing. Okay, got you. I'm sorry.
Oh, it's okay. It's all good. But when the other 3 appears, you got to multiply and then bring it back.
Yes.
Okay. And any other questions? Okay, this time it has bounds on it. So we're gonna have to deal with it once we do the integration. The book and the homework might do it one way or another. I forget which way they show, but these bounds apply to x. So if you do a substitution, you're gonna have to change the bounds. But what I prefer to do is to change it back to x like we did right here from this step to there, and then use the same bounds. That way I don't have to do extra stuff. I don't want to do extra steps because why would I? The book may force you to replace the bounds, but yeah, I think it's unnecessary. So let me show you what I'm talking about. So first, what should be the u?
X squared plus 1.
Yeah, I think that's going to be a good one. And then du,
2x.
2x dx. Okay, do we have a 2x dx?
No.
No, but we have x and dx, right? Divide the 2 out and get rid of it. Okay, so then we can replace, let's show an extra step here. X squared plus 1 cubed. I moved it over here just so it's more obvious that this is being subbed by this. Okay. You don't have to do that, but if you don't see it, hopefully now it makes more sense. So 0 to 1, and then replace the whole inside part cubed, and replace that last part with du over 2. Pull out the 1/2. Integrate this. That will be u to the 4th over 4. I still have those bounds though. What I recommend is change it to x first and keep the other bounds. Also, that's going to be 1/8, right? 1/8 x squared plus 1 to the 4th from 0 to 1. So now I can just use these bounds and not worry about it. I think if you look up other examples, they might do it a different way, and that's fine too. I don't care how you do it. I like this way just because it feels a little bit simpler. So now that it's x, plug in the 1, right, and find out our value. So that would be 1/8 times 1 squared plus 1 to the 4th minus 1/8 times 0 squared plus 1 to the 4th. So that will be what? I don't know. This will be 2, right? 2 to the 4, that's going to be 16 over 8 minus 1 to the 4th is still 1, so that'll be 1/8.
Can you move it down? Thank you.
And that will be 15/8. And that's our answer.
Remember not to put the C because this is bounded.
Yeah, true. If I put it here, then I should put it everywhere. Make a note right here. These bounds are for x. If you wanted to change the bounds for u, you would have to plug it in here. So for example, you plug in the 1 here. The 1 squared plus 1 is 2, so you change the bound to 2. And then I plug in 0, and it'd be 1. So I could use 1 to 2 and leave it like this. So you have to do extra work and plug in numbers there. So it's up to you. I mean, it doesn't matter. Let's see if I can show you what I'm saying.
But the results will always be the same if you do
Yeah,
either.
result will be the same. It's just how the book I think does it the other way. I don't feel like doing it that particular way. Okay. I think that's gonna be. I think that's it. Yeah, that should be enough to get you started on the 5-5. Hopefully, maybe finish it too. Okay, so Wednesday we'll do 5-7, 5-8. Day. Go back. Yeah. So the new homework that you have now is 5-4 and 5-5. I would like you to have 5-4 done before I see you again, but if there's any problems, I'll extend it for you. It's not a huge deal. I just recommend that you finish it that way. You're at the same pace that we all are. You know what I mean? Because it's hard to see new stuff and you're still figuring out the older stuff, but it's all good. So 5-4 by the 2nd at midnight. 5-5 currently is scheduled for the 6th. I'll probably move that. Let's see. No, I think it's a good date. Yeah, okay. So yeah, the dates that are currently there I think are fine. But we'll see how it goes.
You got these notes posted tomorrow? There's a couple of things I missed. I just didn't want to slow down.
I can put the paper notes right away. It's just the
The
video takes time. So yeah, I'll put the notes as soon as possible.
Okay. I mean, I wrote most of them down.